Hello everyone, welcome to Alchemistry and welcome back again. So I am here with the video organic compounds containing nitrogen, and for coordination compounds part 2 I will publish a video very soon. And after completing all the chapters, then I will go for the one short video, and I will prepare and for one short video you have to wait for a while and I will publish it. So today we will discuss about organic compounds containing nitrogen. So once that term comes, that organic compound containing nitrogen, here the thing is, first of all, what kind of organic compounds means? Organic compounds means we are having till now carbon and hydrogen hydrocarbons containing, and there are extra acid group, alcohol group, ketone group, aldehyde group, etc. Now what comes nitrogen? Nitrogen means many nitrogenous groups will be incorporated. Like nitrogenous group means amine group, nitro group, cyanide group, etc. Amide group. This all will get incorporated in aliphatic or aromatic compounds. So that will be organic compounds containing nitrogen. When we are studying the chapter, so better you go through the chapter, you go through the syllabus once. I will follow the reduced syllabus, and here what we are having some basic knowledge. We need some basic knowledge. If you have that basic organic chemistry, that if you have the knowledge clear about organic chemistry is normal. As I told you, every time in organic chemistry, two things we need to know. One, the idea about electrophile, actually three things: the idea about electrophile nucleophile, that thing, idea about electrophile nucleophile, idea about base and acid, where acid reaction base reaction will happen, and the other thing is resonance effect, inductive effect, a hyperconjugative effect, mesomeric effect means mesomeric effect, hyperconjugative effect, inductive effect, etc. If you have knowledge about this all, then organic chemistry is very much easy. So through this chapter, we will discuss what are the main reaction, how to remember the reaction, what will be starting material, reagents, and product. And about basic thing, I will go one by one, tell you with the reactions only. Then you follow that, and you will be and a good concept will be built. And let's start the reactions. Okay, in first part we are having methods of preparation of aliphatic amines. So we are having mainly amines, aliphatic and aromatic. So methods of preparation: from alcohol, from alkyl halide, from cyanide, from amide, from nitro compound, Gabriel, phthalimide, synthesis. So one by one we will just cover up the things. There we are having aliphatic amine. Here from alcohol, if it reacts with ammonia in presence of Al2O3, then it will give you RNH2, just that NH3 attacking from backside and giving you in RNH2 by SN2 reaction. But if that will be 3-degree cation, more we will go towards 3-degree cation, then trend of giving SN1 reaction means through carbocation formation will increase. Now then next again it will react with another molecule of ROH, and it will give you R2NH. Then if it reacts with another molecule of OH, and it can give you R3N. So like this way R3N we can get ultimately. Okay, going to the next question. In the next not question, in the next equation we are having the reaction from alkyl halide. Okay, so reaction from alkyl halide. So if in alkyl halide again ammonia is reacting, because lone pairs are there over nitrogen, so it will act as nucleophile, means electron source, and it will attack to the alkyl halide. Here is the alkyl halide, and the most that leaving group capability of iron is highest, so we can use their alkyl iodide. So when it will react with NH3, suppose this one is 1-degree cation or steric hindrance is not there, so it will follow SN2 mechanism and we will get that. Or suppose this one is a tertiary carbocation, means tertiary iodide, then first this iodide will leaves the group, and for this case some catalyst we need to use to make it a leaving group, and we will get the corresponding carbocation. Then again amine will act as a nucleophile, and it will give you corresponding amine, means amine, aliphatic amine. Okay, in the next part we are having arsenide. Here we are using LiLH4. This one is reducing agent. Reducing agent, that means source of H minus, and it will attack to carbon, then nitrogen, and it will give you RCH double bond NH, and then after again attacking of another hydrogen, here RCH2 NH2 will form. But if we add, after this step, if we add here Suppose if we are adding water here, then that R CH double bonded NH will be converted into R A CH double bonded O aldehyde. So these are the reactions. Then we are having another reaction. That one is Gabriel phthalimide synthesis. In Gabriel, so it is mentioned there. We are having Gabriel phthalimide synthesis. So in the Gabriel phthalimide synthesis, here we are using phthalimide first. Phthalimide we are using. In presence of potassium hydroxide and Ri, it will convert it into corresponding amine. So how this reaction is happening actually? By adding potassium hydroxide. Potassium hydroxide means the base. And in the phthalimide, this hydrogen attached with nitrogen, this one is the acidic hydrogen. How? Because if this hydrogen will get captured by the base, it will give you negative charge over nitrogen. So as it has given you negative charge over nitrogen, by reaction with alkyl iodide, this will attack to the alkyl part, and then again it's into type of reaction, and here we will get this thing. And after getting in our compound, then by addition of base, again this base will attack here, this base will attack here, and this part will come out in the form of NH2, our corresponding amine, primary amine we can get by Gabriel phthalimide synthesis from phthalimide by using potassium hydroxide and alkyl halide. So you have to follow what are the starting material we are using, what is the starting material, what are the reagents, and what will be the ultimate product. And then in the next case we are having RNO2. That RNO2 reaction I will show you later, that actually will form RNH2. By this one also, by reduction we can get amine. Then this one is amide. Here amide to amide we are adding bromine KOH. This one is the Hofmann degradation reaction. Hofmann degradation reaction. So in Hofmann degradation reaction we will get RNH2, so that CO part will come out. This reaction will happen like first in the by application of potassium hydroxide base. Here it will convert into NH negative. That NH negative will capture one bromine and it will form. Then again NH negative will form. So N negative Br, and by here some rearrangement will happen, and then after the rearrangement bromine will come out and it will form this N double bonded C double bonded O. Isocyanate intermediate will form. So ultimately after isocyanate intermediate formation, then base will attack and it will give you the corresponding amine. So we don't have a mechanism in our ICSE level, but I have told you to remember the things very well. I have told you the mechanism thing. Reactions we can get the corresponding amine. Okay, next we are having some chemical properties and basic nature of our amine. If we go for ammonia, ammonia is basic. We all know about that. Ammonia is basic in nature. Now we have added with it one alkyl group. This one will also be basic in nature. Because of addition of alkyl group will have that plus I effect. Alkyl group will have the plus I effect. Because of plus I electron donating effect, the electron density over nitrogen will increases. So more the number of alkyl group, that basicity, basically this one is Lewis base, because it is donating in lone pair, so basicity will increases. So in R is 2. And again, if we are going for the aniline, the aromatic amine, for this one is benzene ring, and here is the NH2 group. And here this NH2 group will show plus R effect and will involve in the pi conjugation with the benzene ring. The lone pair will go towards the benzene ring, and here plus R effect will be shown by NH2, and because of that these electrons are actually involved in resonance with benzene. So that's why these electrons will not be that much available like aliphatic amine. So this aromatic amine will have less basicity than aliphatic amine. So this one is the case. And if we consider the Placer effect of amine, it will increase the electron density at ortho and para position, and here electron deficient position will be meta position. So any nucleophile will attack to the meta position. Any electrophilic reaction will happen. Electrophilic reaction will happen first at para position, then at ortho position. Okay, then going for the reactions, alkylation, acylation, carbylamine reactions, etc. Okay, let's go for it. So here that aniline will react with potassium hydroxide along with CaCl3. It will give you actually dichloro-1 carbene type of intermediate, and after that it will react with the nitrogen center. It will give you pH N triple bond C, the carbyl amine. So it will give you the carbyl amine, and this one is a carbylamine reaction. And carbylamine have some strong smell through which we can identify whether in the medium there is aniline present or not. Then we can go for distinction, or we can distinguish between primary, secondary, tertiary amine. Let's go for it. And the carbylamine test also can be applied in case of aliphatic amine. There also we can get, suppose from methylamine we are doing the carbylamine test, MENH2, and it will react with KOH and CHCl3, then it will give you methyl carbylamine amine. So N will be first isonitrile group, nitrile and isonitrile. Okay, next we are having that thing, the distinction between primary, secondary and tertiary amine through Hinsberg test. In Hinsberg test, our reagent what we are using is benzene sulfonyl chloride. Benzene sulfonyl chloride. Benzene sulfonyl chloride. So when it will react with primary amine, it will directly react and it will give you a salt of sulfonium amide. It will give you a salt of sulfonium amide. This double bonded O, and here N are in a positive, salt of sulfonium amide. But if we are using secondary amine here, so this N negative can be formed if there is extra hydrogen present. But if we are using secondary amine, in that case it will react with benzene sulfonyl chloride and it will give you NR2, but as there is no hydrogen left, so it will not give you the corresponding salt by addition of sodium hydroxide, where previously it has given the corresponding salt by adding sodium hydroxide. So after adding sodium hydroxide, no salt will be formed. And here, so it will be insoluble in aqueous sodium hydroxide. Whether if we were having the tertiary amine, here no hydrogen is initially, also no hydrogen is there. So if no hydrogen is there, then it can't react with benzene sulfonyl chloride. It can't react with benzene sulfonyl chloride. So if we add sodium hydroxide here, salt of this benzene sulfonyl chloride will form, and here tertiary amine will be like this only, and by addition of HCl it will give you the salt of HCl, that salt of chloride salt. Like this way we can distinguish between primary, secondary and tertiary amine. So how this reaction will happen? With aniline HNO2 in presence of dilute HCl, 0 degree to 5 degree centigrade, it will give you diazonium salt. So how this reaction is happening? We are having HNO2. By addition of H plus, it will give you nitrosonium ion NO positive. Then we are having here NO positive, means this one will be our electrophile. So in the aniline, here lone pair of nitrogens are present. This can act as the nucleophile. So if it will react as nucleophile, so it will attack at the nitrogen positive charge electrodeficient part. So after reaction with that, it will give you N double bonded O. Here a positive charge will form with 2 hydrogen, and a rearrangement will happen. After the rearrangement, over nitrogen there will be no charge, whether it will give its one of the hydrogen to this oxygen, and then this OH double bond will open up, and one water molecule will come out, and it will give you ultimately that N triple bond N, here positive, N2 positive. And that after formation of diazonium salt, it can participate in various kind of reactions. Suppose we are having here some reactions like HNO2 HCl diluted 0 to 5 degrees centigrade, it will give you the diazonium salt. With this, if copper HCl is reacting, it will give you the Gatterman reaction, where chloride as the diazonium salt in 2 positive. This bond will be very much breakable, and by addition of any chlorinating agent, chlorine will get added to the benzene. And here also we are using Cu2Cl2HCl Sandmeyer reaction. If we use Cu2Br2HBr, then it will give you corresponding bromide. If we are using chlorine source, it will give you chloride. An interesting reaction of diazonium salt is the coupling reaction. In coupling reaction, suppose we are having this one is the alcohol, okay? In presence of base, suppose it has formed O minus. As we know here also that resonance possible at the para position, electron reach, it will be electron efficient. Now through the para position, now what type of reaction will happen? This one is our O negative and this one is para position, and here the diazonium salt is present. Now this will attack through the para position and it will give you the corresponding coupling reaction. So after coupling, they have coupled, and this one is called the coupling reaction. Actually, with this coupling, that ultimate product will have a proper significant color through which we can identify the presence of diazonium salt. And if this coupling reaction is happening in between diazonium salt and 2-naphthol having the formula 2 benzene ring used, this one is 2-naphthol. So in presence of base sodium hydroxide, pH 9 to 10, it will react with the diazonium salt, and after coupling it will give you the corresponding dye of orange color. So through this orange color dye also we can indicate the presence of diazonium salt, as well as we can indicate the presence of aniline. Like previously, these bonds will get opened and we will get this. Here will be the OH in the form of O negative. After hydrolysis, it will give you OH. So this one will be the orange. So in short, I have explained all the reactions and the basic thing of nitrogen compound. If you like this video, please give a like and share with your friends, those who will give ISC exam. And if you have any doubt, any question, comment below. So that much for this video, and thank you for watching.